this talk takes a slightly different angle and about a very hard type of system if you want to scale them. So let's say you need to write stateful service. You need to deliver live updates to your users. You need to actually, like most of the system you have built, if you're doing microservices, are about request response and synchronous interactions. How do we handle when something is stateful and we need to deliver live updates to your user? So today I will be demoing this thing that I have built called UpRing. It's a framework for doing application level sharding for Node. Now, I hope my demo gods assist me. We have been running into problems already, so we'll see how that goes. So first of all, let me start the thing up. So I'm opening up the demo. You see there's a nice Tmax shell, which I use to automate, because who needs Docker? You see, Tmax is perfect for running a bunch of microservices. So first thing that you want to know is this thing. This is UpRing. It's a control panel for UpRing. UpRing is based on a consistent hashing. We will see how that works in a second. I have a bunch of peers on the right. Those are my servers. Okay. The key property about UpRing is that you can store data on the system. This is a key value demo. It's a framework. You can use it to build whatever you want. So what you can see is, well, we can put things like slash here, and it will be handled by this node. You see, this node is port 3042. We also have a nice Nginx running on top, because who knows. So if we go around and we talk to my Nginx, we see slash, well, it's a 404. Yeah, let's store some data. So we can do a little curl. I hope you all like curl, because I love doing curl. I do curl all the time. So hello world, because that's what you do. And well, we have to store some data. Now, in my control panel, you'll see that it got 2 hits on that specific peer, which is running on my system in port 3042. And if I refresh this, you will see the hello world. Now, where did this go? This was handled by any of those peer. In fact, you know, we can also do something more interesting. So, for example, we can check where is /Matteo is going to be handled. Matteo is going to be handled here. You see, still the same 3042 guy, but with a different part of the hash. Let's try something else. So let's try /MSD. Yeah, another peer. So I got another little bit of variety, 3043. You see there is also a request for 5icon.icon, whatever. I should have masked that. So let's start. It was MSD, yes, MSD. And let's store some data here. MSD, yeah. And again, over here, went there. So if I go in my browser and I hit MSD, I will get my data. Yeah. What I've built here is a little key value store. So now, this is a key value store, Redis, whatever. Who the hell you need to build a very complex distributed system for doing that? Now, let me show you some more interesting stuff. So what I can do with this system is I can check something like this. I can ask for live data. Now, you see these server-sent events for very dummy server-sent event thing that I've built. Now, I can pass some more data to my thing. So I say, hello, Matteo, and you will see it get data live updated. And yeah, well, it's still receiving the stuff. So the key important property of this system is what happens when a peer dies. So we have a live connection, you see, to the guy. But if I go here and MSD is being handled by this peer hub here, so 3043. Now, 3043 is handled by this panel. You see there is some stuff. I killed it. My service is done. Now, you will see that my control panel here has completely rehashed himself. So we have just 2 peers. And this data now is being handled by this peer here, which is 3044. Well, let's try refreshing this. Woo. 7, and here we go. This connection went here, and yeah, still everything is still running. So what happens now? The data was moved, and if I start this back on, here we go. You see a replicated key here. It got some data inside it. And you see the thing has been completely rehashed. It completely rehashed himself. And now it's being handled. It's still handled with the 044, but I've got a new peer, and the data has been moved and changed. So, well, what all of this is and what does it matter for microservices or PubSub systems. So this was the demo. So the big question is, what if we want to support live updates with our user? How we deliver live updates? How we move data around? How we have data flow? This is what happens when you try to do live updates normally. You've got two servers fighting for the data. How many of you have tried to do WebSockets, live WebSockets connections? Yeah, somebody felt the huge pain of doing. How many of you have fun with sticky sessions? Somebody laughing. This is what happens with servers and sticky sessions most of the time, OK? So, well, probably not nice. The major problem is how can we know which node will handle what connection? So how do we match a server with a connection? OK? This is the problem. Now, I don't know. I did a nice school in Italy, doing a lot of classic stuff. So divide et impera, don't know. It's a principle to win wars in particular. It also works for microservices and servers. So this is what our application level sharding means. So you see we are doing some requests, and all the data for user 1, 2, 3, 4, 5 goes to the same server, so that we can actually route the data so that that server manages that particular information. So we can hold state there. We can do stateful microservices. So the problem there, if you want to implement application level sharding, is how do we assign data to servers, OK? Now, what we can do very naively and say, well, all the users between 0 and 100 goes to that server. Very nice way of doing this. Very scalable, very resilient, very robust. No, what we do with UpRing is something slightly different. So we are using an hash-based system. And so for every key that we want to put in our system, we do an hash of it. And we hash it to 32 bits. Now, the beauty of 32 bits is that it's a circle. It's a key space that goes from 0 to 32 bits, and then goes back to 0. So we can organize our peers in a circle. And we can say, well, if a key matches, so we can hash any key you want to 32 bits, and then place it on our circle, on our key space. And we can have multiple peers, A, B, and C, be responsible for that specific part of it. When we write, so this is what happens when we read. We hash the key and go to the specific peer. But when we write, we go and do 2 copies of it, so that it can be resilient. Okay? All of this is based on the Dynamo paper from AWS. You read this paper. It's probably one of the best papers in the last decades. Really worth looking into. This is strategy 1, which is what you implement. There are other strategies, whatever. Again, I didn't invent any of this. I just did my own implementation. The big question is what happens when a peer dies. You've seen that happening there. It's if a peer dies, well, how do I reallocate my key space? Well, this is what happens. This is your state. You are going to the load balancer, and you have your hashed key to peer A. What happens is peer A dies. Peer B, that is the next one in the key space, takes over that chunk of the key space automatically. And because we have copied the data on write, it already has all the data. So there is no data movement. Now, what you will need, there's still some data movement to update the other copies of the data, because you need to move that responsibility, but you handle failover instantaneously. Well, this is a problem. How do we know if a peer has died? This is a key major problem in computer science in general. How do we know if a peer died? Split brain, have you ever heard about split brain problems? These are very nice things to get into. So in fact, knowing when a peer dies, if a peer is alive or not. It's like searching a book here. It's not nice. This is a very nice picture. The solution to this problem has been done by another paper. Hey, a thing called Scalable Weakly Consistent Infection Style Membership Protocol. Swim. Fantastic. You should use this. In fact, it's a nice paper from Cornell University. So again, another paper that might be worth reading if you are into a little bit more sciencey stuff, whatever. I have a PhD, sorry folks, I'm into papers. Anyway, Swim is a really nice protocol because it's gossip based. So it means that all the peers chat between themselves and they can converge in a very large network of thousands of peers can converge on knowing whoever else is online and available in a matter of milliseconds. So it's really, really fantastic. So, well, what UpRing does, it's a nice idea. It's organize the peer in a consistent hashing using Swim to detect failures. Now, you might have heard about some of this stuff. There is a other nice framework called RingPop from Uber. That's how Uber works. So, and well, no, it's not magic, okay? It's definitely not magic. So what it does is that the consistent hashing, so you see we have our hash, so that everything between 0 and a point by A, the hash of our ID goes to one server, between A and B goes to the other, between B and C goes to the another one. Now, have you heard about Raft and Paxos? Yeah, some little folks. So the Raft and Paxos are techniques to do distributed system and to enforce and to build databases and to enforce a coherent model of your system. Now, one of the major points is in UpRing, you don't, the leader for the specific key is statically decided based on whoever else is available on my network. In Raft and Paxos, the leader is elected. So there is one single leader or multiple leader in case of multi-Paxos that is elected by everybody. And so that's always the same guy for all the keys. So in one case, everybody writes, and in the other case, there's only one elected. Now, Raft and Paxos is really hard to implement. Has anybody here that have implemented Raft or Paxos in their life? Have they tried? Yeah, me neither. So again, a little bit more sciencey stuff. In UpRing, the stability of the cluster and the fact that your peer-to-peer network still works, it depends on the gossip network and Swim. Because you need to know which is available when you hash the key. In Raft and Paxos, you need at least 3 nodes to operate, but better be 5. Now, you have probably heard about the 3-node and the 5-node things. etcd, console, all those are based on Raft, okay? If you're running an etcd cluster, you need 5 nodes, ideally on 5 different physical machines. Because if one breaks, now I've seen that doing my consulting job, I've seen some nice deployment of etcd where, well, I put 5 of them all on the same physical machine on different VMs. Yeah, but it doesn't work, okay? If that goes down, you're done, okay? So it's a big investment in hardware. So be careful, that's usually a big problem. By the way, if you're using Kubernetes, you have an etcd cluster down there. So at some point, so be careful. With UpRing, it's way simpler to operate because you just throw it up and it doesn't have all these minimum requirements. So back to the original question, how can we build a PubSub system with UpRing? So same problem, instead of having a key value and read and write, we have publish and subscribes. When we publish, we hash our topic and allocate it to a node, and then we replicate the publish. And when we subscribe, we open a live connection. Be careful. We open a live connection to a peer, to the given peer that is handling that thing. The key point is all those live connections stays open, so we can actually have a WebSocket connection and keep our channel live. Another thing you might want to use this system for example, is, well, I have some bunch of long-running requests, and I fire them up, and then they say, well, deliver all of this to UpRing, and then the UpRing server can actually forward that to the end-up client. So now there is the point where our MySubscribe cannot, given that we might have a round-robin server, we don't have no sticky sessions with the system. So got rid of sticky sessions. We have, and that subscribe can go to whatever peer we want. So even if in case of a split brain situation, B, if A has just come online and B doesn't know about it, and the request gets routed there, it's fine because the publish will go to A, and A will propagate it, so it will scale. Now, in publish subscribe system, you also have wildcards, OK? Now, with wildcards, if you want to subscribe to all messages, it's easy, but it also supports a more limited number. So it will just, if you subscribe with a wildcard, it will just connect to the peers that are actually handling that type of topic. So now I have a demo of my PubSub system. Will it work? Will it not work? May the demo gods be with me. So first of all, we kill all my previous system, because I'm not using Docker. You see, I am a Unix guy, and I just use Tmux. So demo chat. So I boot up my nice session. So let's close a bunch of stuff. And we can check if my UpRing cluster is still on. Now, my Nginx now is trained to do something different. So this is my PubSub system. Do you like the design? I did it. I'm a very cool designer, you know. So you have a subscribe and publish button. So let's try that. Let's subscribe, and then publish. So hey, it's working. OK? Well, let's open up another box. And let's see. Let's publish stuff. So hello, word. And here, it's getting my data. OK? As you can see here, it's all handled by this peer here, 3043. That's my peer. Hey, let's kill it. So hey, this guy has been doing fine. Maybe, maybe not. Who knows? So hey, it's still working. An applause, come on. Thank you. It's still, what we can do is we can also subscribe to, for example, hello plus. This is a little wildcard thingy. So we subscribe to all messages hello, so hello plus. So from here, we can publish to hello Matteo. And here we go. This guy got the full message. We can also publish to hello world. And still getting it. And we can go on for probably half an hour playing with this UI. I had fun from time to time, booting it up and doing it. So, just wrapping it up, UpRing is a framework to build a key value store. You have tried it, you have seen it, it's little demo. A cache, why? Why a cache is important? Well, microservice system, we've talked about caching like a couple of hours before. So, our PubSub system, we have seen that. A real-time application, why not? A discovery system for your microservices in place of whatever you want to use. A metadata store, or another piece of infrastructure you want to throw at it. The key point is it's a way to handle distributed state in an eventual consistency manner. So if you're running etcd or console, any of those systems are strongly consistent. Now, this is a key property. Those things are strongly consistent. They need 5 peers to run. Okay? This system is not strongly consistent. UpRing is eventually consistent. So it's a different design. But it's easy to operate. So you just boot it up, and it will work. So some links to close it off. First of all, UpRing over there. UpRing KV is the demo of the key value store. UpRing control, it's the UI that I've just showed you, the nice D3. I had fun with D3. UpRing PubSub is the PubSub system that I've just demoed. All of this is open source, MIT licensed, so you can try it, see if it doesn't work on your machine. In that case, open an issue. And this presentation is available here and here. OK, one is the source, whatever, HTML5 type of things. I'm a JavaScript guy, Node, so hey. I want to say some thanks to all of you, and also to my friend Luca that helped doing this presentation, and I've been driving some of this work on the consistent ushering. I work with nearForm. I don't know, you probably have been to this event, so we know about us. Hey, Kian. So, and thank you all.